All right, our last regression, we're going to be doing exponential regressions. Okay, so we're looking to create equations that are in the form y equals a times b to the x power. Remember, a is how many of something that they started with, it's like your y-intercept, and b is what you're multiplying by. Okay. It says, every hour a scientist records the number of cells in a colony of bacteria growing in her lab. The sample begins with 15 cells. Predict the number of cells in the colony after 7 hours. Okay, so we're going to go to Stat, Edit, and my data from the previous video is still here. I'm going to delete it out. So I've got 0, 1, 2, 3, 4. Okay, and my number of cells, I've got 15, 40, 110, 300, and 850. Okay, so before I leave this screen on my calculator, I'm just going to double check and make sure that I don't have any typos. Okay. So we are doing the quadratic regression. So we're going to go to Stat, Calc. Quadratic regression is option 0. It's under the 9. We don't have to scroll to it. I remember that it's there, and I just hit 0. You can scroll to it, but you don't have to. Okay, so we have an A value of 14.75. and so on. We have a b value of 2.742, blah, blah, blah. And we have an r squared and an r value. Okay, so if we were comparing with linear, we would use the r. If we were comparing with quadratic, we would use r squared. Okay, so in this case, we're just going to use r because we're not really comparing it to anything. And holy cow, 9's out to 4 place values. Okay, very, very, very strong correlation. Okay, now for the equation, y equals 15 times 3 to the x. Now that's rounded, and I kind of want to show you guys something. Okay, so y equals, we're gonna talk about rounding and how rounding affects your graph, 3 to the x. So we rounded these numbers to whole numbers, and if I now hit zoom 9, it's going to show me my data and my equation. Now what I notice is that the exponential graph, the line part, starts out touching our dots, but then it starts to work away from our dots. And I would say that's because we rounded up to 15 and we rounded up to 3. So I just want to point out that if we go back, and I need the screen here. If we go back and round differently, okay, I'm rounding here to 2 decimal places instead of whole numbers, all right, and I'm going to do that graph underneath so you can see both 14.75 times 2.74 caret x. Okay, so I just want to show you the effects of rounding and fit. Okay, so the blue line that is already there, but watch what happens when I use the red line. Okay, the red line with less rounding, okay, so we have 2 more place values, that means we rounded less, is a much better fit. Okay, so that's why often at our level in algebra, we don't round to whole numbers very often because you get a much better and more accurate graph, okay, with more decimal places. So for the purposes of doing our prediction, though, I will stick with the whole numbers, okay. So if I type in 15 times 3 caret, whoops, no times sign, times 3 caret 7, and it's probably not going to like that square, so I have to take it out. I get an answer of 32,805 as a prediction. Okay. Thanks for watching. See you next time.